So looking at exterior and interior angles of polygons, we're going to use this chart and work our way through it to kind of come up with all of our different equations that we'll be using for these types of questions when we're asked about interior and exterior angles of polygons. So we're going to start off just going down in order. Column 2, okay, let's start with A. In column 2, it asks us to identify the number of sides of the given polygon. So we've already got that example. With that triangle, we've got 3 sides. With our quadrilateral, we can see that we have 4 sides. With our pentagon, we can see that we have 5 sides. 1, 2, 3, 4, 5. And then, so it stands to reason, and this bottom row is going to be kind of where we make our rule. If a triangle, we see 3 sides. Quadrilateral, we see 4 sides. Pentagon, we see 5 sides. An n-gon is an n-sided figure. So it's got n number of sides. We can replace n with 17. We can replace it with 22. We can replace it with whatever. So we will just say that for column 2, an n-gon has n number of sides. Okay. So we'll use those prefixes for each one of those. It does ask us to, in column 1, for B, column 1, draw diagonals to the other vertices of the polygon from point A. And then in column 3, identify the number of triangles we form. So if we look here, there's no point A. There's just one triangle in the triangle. Kind of makes sense. So let's go down to our quadrilateral. If we start at point A and draw a line across, then you can see we create 1 and 2 triangles. So in column 3, we have 2 triangles over here. For our pentagon, go from point A across, go from point A across, and that creates a triangle right there. We also have triangle on the left side, and we have a triangle on the right side. So we have 3 triangles here. So if we take a look at our column 2 and column 3, 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2. So we can use that to help us write our equation. For a number of triangles formed, we're actually going to say n minus 2. Because if we took 3 minus 2, we end up with 1. Minus 2, we end up with 2. Minus 2, we end up with 3. So if we take n minus 2, we end up with our rule in column 3. Now we go to column 4, so we're looking at C. In column 4, find the sum of the interior angle measures of the polygon. And our hint is we take the number of triangles and multiply it by 180. So in a triangle, we only have 180 degrees, so that kind of makes sense. Our number of triangles times 180. We only have one triangle, so we know the sum of the interior measures of a triangle is going to be 180 degrees. Down here at quadrilateral, we said we had 2 triangles, so we multiply 2 times 180 to get 360 degrees. For our pentagon, we had 3 triangles. 3 times 180 is going to be 540 degrees. And then for our rule, we're just going to take our number of triangles, which we know is n minus 2, and we're going to multiply that by 180 degrees. So we've got all the way through 4 columns. Our 5th column, if we take a look at it, says identify the number of linear pairs and multiply that by 180. So remember, linear pairs are 2 angles that are adjacent to each other and form a line. So we can see that we have a linear pair right here, a linear pair right here, a linear pair right here. We have 3, okay, we have 3 linear pairs, so we multiply those by 180 to get 540. Over here, okay, we have 1 linear pair, 2 linear pair, 3 linear pair, 4 linear pair. So we'll put a 4 right there. We'll multiply it here in a minute. We got 1, 2, 3, 4, and 5 linear pairs here. So we take 4 times 180, and that's going to equal 4 times 180 is 720. 5 times 180 equals 5 times 180, not 720. That's going to be 900. And so here, we just say n times 180 because if we pay attention, we have the same number of linear pairs as we do number of sides. So we would just take all of that and multiply it by 180. Our exterior measure, okay, so let's look at column 6 for a second. Column 6 says take the result from column 5 and subtract the result from column 4. And that's going to give us the exterior sum because we know linear pairs are 180 minus, or they're going to add up to equal 180. So if we know what the interior angle measures are, then we can figure out what the exterior angles are. So column 5, we said we know how many total degrees are created because of our linear pairs, okay? And we can subtract that from the interior angle measures to figure out our sum of exterior angles. So if we kind of take a look, we've got our 180 in blue, we've got our 540 in orange. So we're going to subtract those out. 540 minus 180 equals 360. And then I'm just going to set everything up and then do all my calculations at the end. So we've got 720 minus 900 minus, let's add our blue. So 360 equals 540 equals, so 720 minus 360, that's going to equal 360 as well. 900 minus 540 equals 360. And if you're paying attention, you can see a pattern. No matter what, column 6 says our exterior angles are going to always equal 360 degrees. So that is our chart that we can use going forward to help us come up with the sum of the interior angles and the sum of the exterior angles.